Hello guys, my name is Eduardo Reyes, my partner is Max Cohen, and I'm going to show you how to do part one for this project, and my partner is going to show you how to do part two. So this is going to be the final exam and project for this class with OSBE, this aerospace experiments. So for the first part, we're going to do this right here. So a 2D flow simulation over a NACA 2415 airfoil using a free-stream velocity of 15 meters per second. And we're gonna use that airfoil at different angles of attack. And we're gonna get the CL and the CD values from report definition from ANSYS. And also we're gonna get the velocity and the pressure contours out of these airfoils. So velocity and pressure contours. All right. So first of all, we need to go, this is how I did it. So I just went to this web page right here to get the airfoil. So you just go to airfoil plotter, look for the one you're looking for. So in this case, this is 2415. So this one right here, got apply. And then CSV file of coordinates. So this is gonna download the coordinates and we're gonna put it on the Excel file in an Excel document. So after you do that, so after you do that, you just open that Excel file and you're gonna just put this in a notepad so you can import that to ANSYS. And also the way you need to do it, and just creating the points in here, as you will know from my previous video for project 2. So just create this in a way you can import that to the notepad and then import that to ANSYS. After that's done, then we're gonna import it in our geometry. So I'll just go back to the geometry so you can see, yeah. So you just import it as a curve, it's right here. Just then create the rectangle around this airfoil. So this is gonna be your volume control. And then yeah, just create the surface, then do the Boolean part. So you got the line body and you got the surface body. So after you do that, so after all that, what are you gonna do? So this is for the first part, at 0 angle of attack. Then what you're gonna do to do the different angles of attack is just going here to create body transformation and then just rotate. So select that and start rotating your airfoil to the different angle of attack that you'll need. And after you do that, just run the same simulation I'm gonna show you after you have like the different angle of attacks. Okay, after that, we just go to mesh. So I'm just gonna show you here what we did in mesh. So we got the geometry right here, line man, surface body. So I use the all triangles method for this mesh, and I use this name selection. So inlet, outlet, this is the airfoil, and then the wall. After you're done with the name selections, you created a mesh, you select the element size that will work for you. In my case, I selected 1 meter, so it looks like that. Just generate the mesh, and that's it. After you got your mesh, just go here. So just make sure you have your energy on. Also, I use the laminar equation for this. But most important, yeah, just make sure you got your air, fluid, same as previous projects. And then some boundary conditions. Just make sure you go here and you put 15 because that's the velocity magnitude need. So just make sure you have 15 in there. And in reference values, just make sure you input that from the inlet to the surface body. And just double check here for here that the velocity is 15. And after all that is done, just go to report definitions so you can get the lift coefficient and the drag coefficient. And well, before all that, you need to do the analyzation. And after that's done, so do the analyzation right here. I'm gonna go here, hybrid, and then do it. And after all that, get to run calculations. I'll select 100 number of iterations. Just calculate that. After you go on that, then you can get the contours and you can also get your report definitions. So the contours, just go here to contours, pressure, static pressure, just select everything. Save on this, like compute, save on display, and you're gonna get something like this. This is the pressure. And then for the velocity, just do the same, select everything, velocity, velocity magnitude, compute, save on display, and you're gonna get something like this. Yeah, so just repeat all this process with all the angle of attack that you need. Also doing the report definitions, going here, going to force, and then drag and lift, get your lift right coefficient, get it for all the angle of attack, same with the contours, and just tabulate all those results, put the figures together, and that's gonna be all for part one of this project. Thank you so much.